A very important concept in algebra is learning how to factor. So this video is going to just review some of the important concepts for factoring. The first thing for step number 1 that you'll always want to do is that you'll always want to factor out the greatest common factor if possible. And it's not always possible. What it is, that's the very first thing that you'll always want to do. The second step that you'll ask yourself is, how many terms do I have? By knowing how many terms are in the problem, that's going to determine the method that you're going to use for solving or for factoring. So if you happen to have 2 terms, it's a different method than when you have 3 terms, or when you happen to have 4 terms. Now, when you have 3 terms, it's what you've been taught in the past by doing the trial and error. And we'll review later some of those concepts. And when you're talking about 4 terms, you do what they call grouping. Now, the one that I'm going to review more is what happens when you happen to have 2 terms. Well, the very first thing you'll do when you have 2 terms is you'll look to see if you happen to have what they call the difference of squares. And when we talk about the difference of squares, it's where you have 2 terms. The first one is a perfect square. Difference means a minus. And the second one is also a perfect square. When that occurs, you'll have 2 sets of parentheses, 1 plus, 1 minus. You'll split up the first term and the second term. Difference of squares. Now, there is no sum of squares. So if you ever are encountered with a problem that even though the first one happens to be a perfect square and the second one is a perfect square, but they're separated by plus, what you'll do is say it's not factorable. You cannot factor a sum of squares. The next one is then there is something called a difference of cubes and also a sum of cubes. Notice we do have a sum of cubes, but not a sum of squares. So let's look at the difference of cubes. The first one's a perfect cube. The second one's a perfect cube. So what do you want to do? You'll want to set up 2 sets of parentheses like this. Whatever sign you have here will always go in your first set of parentheses, and then go ahead and put the other signs in the other parentheses. Whatever the first term here is, you'll take the cube root and the cube root. Now to fill in the last 3 terms, you'll use this set of parentheses. Take whatever term you have here and square it. Take the last one and square it, and then just multiply the 2 together. And then you'll want to do the same thing when you happen to have a sum of cubes. Notice we have a perfect cube plus and another perfect cube. Once again, set up your parentheses. Whatever sign you have here will always go in your first set of parentheses. And notice the difference here. One's minus, one's plus, which is a little bit different than what we had before. So I'm going to take the cube root of the first one, the cube root of the second. Now, to fill in the remaining 3 terms, I'm going to do the same thing that I did when I was doing the one previously. I'm going to take the first term here and square it, take the last one and square it, and then multiply the 2 together. Therefore, that will end up giving me now the sum of cubes and the difference of cubes.